Okay, great. Yeah, so welcome back to the formal methods exercise, formal methods for software engineering. Just a reminder, we were basically working on formalizing this table, and we had, lots of fun trying to do that. And in the end, we came up with some formalizations which might not work so well, and some others which were giving us surprising configurations that we didn't want. And then so that's really maybe a good. I like that we did all this because it's a good lesson to show that formalizing even very simple problems can be very tricky and very difficult. But this is exactly what we need to do when we want to apply the formal methods tools to actually solve some software engineering projects or other kind of problems or other kind of problems. But of course, we're mainly interested in problems that we have from software engineering and that we want to solve using formal methods tools. So yeah, we looked at this rule-based access table and we have these constraints. And we wanted to check whether these constraints are actually valid on this table or whether they can be violated. So we said, well, we're going to use some variables to express the relations between the resources that people can have access to and the roles that people can have. And people can have multiple roles. So in theory, there's somebody who could be admin, HR, and support. Maybe some people even have no roles. Probably a nice check would be that if you have no roles, you also have no access to any resources. But yeah, something like that we could encode. And basically, this slide came up as one of the possible formalizations of the declarative access rules. So this was basically how we ended in the last session after we. It's not a permalink. No, not a permalink. So I have to type them up. So yeah, this was basically one of the insights that this might be a formulation that might work. So the idea here was that we say you have access to some resource if and only if you have one of these roles. So we have basically an or between the roles that you could have. And then we say you only have access to this role when you're really one of these people. So now this, when the table changes, we have to maintain these constraints. So let's say there is a new role with access to the knowledge base, then we would have to edit this constraint, right? We can't rely on this constraint to be there and always be valid. Even simple additions to the table require us to change this constraint. That's why in 1 or 2 weeks, we will actually try to see how we can automate these kind of things. So we come up with a translation and then we first do it manually. That's the first step always, to see how can I even represent this in the logic in the tool. And then later we can try to automate this. So one of my colleagues, for example, he did this for some Amazon Web Service configurations. They automated the translation of the configuration files to an SMT solver, and then they automatically analyzed it for known vulnerabilities. So yeah, but here we're still doing this manually. So this is, I didn't create a permalink for this. Okay. Yeah. So that's one. And basically these different access rules here. And the last one, access firewall, if and only if we are an admin. So now we have our declarative access rules. What we did last time is we basically said, well, all of them have to hold, and then we looked at some possible things we can do. So we could do that again. We can just say, well, we want this one to hold. We want this thing to hold, and we want this thing to hold. Then we can look at, now if we're checking it for satisfiability, we're looking at some examples. that would satisfy the formula. Is the size fine? So I forgot to introduce Shoaib. For those of you who don't know him, that's Shoaib. And he's the guy maintaining this very nice formal methods playground. So yeah, and he actually implemented a new feature. I don't know, is it deployed? Can I resize this? Yeah, very nice. So and we have now colors of the brackets. So yeah, very nice. Yeah, so this tool is basically this semester we are using this for the very first time. And in case there's the need for improvements, we will try to improve it. So the idea is basically to make it even much easier for everyone to get started with using these tools. You can also install them, of course, locally on your computer. I think this Limbool Home would have some binaries of Limbool and also the source code if you want to compile it for yourself. Okay, so yeah, now I hit the run button, and what we get is we get an example that satisfies these rules. So yeah, we see this. What is this? What is this example? It says no role and no access. What does it mean? What does it characterize? We have some very, very general rules, right? And these are for basically every element of the table, right? Somehow, or for the relation between access and roles. But what is this? This is a concrete example. So this on the left side is our role-based access table. This on the right side is what? Is it a cell in the table? Not really, because a cell in the table would be some role and some resource that you can access, right? So it's not a cell in the table. What is it? In terms of our domain, we could say this is characterizing a user, an individual user, or a group of users. All those users that have no role, right? All the roles here are false. And then all those users that have no access to any resource, right? So it's basically an example of a user or a set of users with similar properties, right? So should we see some admin user? If we say is admin, right? Then if we run it, we should get some admin user. And we see, well, we get access to the knowledge base and the firewall. Is that, we can sanity check this. Yeah, makes kind of sense, right? Now we can add, of course, more stuff. We can say is admin, is HR, and is support. What are we expecting? If a person has all these roles, we have access to, wait, is HR. That's a tricky thing. Here I misspelled. Instead of is HR, I wrote IDHR. And that's maybe a shortcoming of this language, because this language doesn't distinguish between using a variable and declaring a variable, right? By using a variable, I'm automatically declaring it. So this means by misspelling this variable name, I declared a new variable. So IDR, well, it sets it to true, but ishr is still false. So yeah, we can discuss whether this is a good language design of the language or not. We will see other languages. The next one that we will look at, you have to declare variables first before you can use them. And this way, if you misspell a variable when you use it, it's not going to create one automatically for you. Okay, so now, yeah, we have some person who is support, is HR, is admin, and they have access to everything. So these rules, this gives us some confidence, right? That these rules might express our table. Okay. Now, But what we actually wanted to do is we didn't want to do this stuff. We wanted to do, what I just mentioned is now we're basically modeling a single user. And well, this is so basically for the next thing, we're going to model a single user, and then we're going to use a validity check. So to check that all the constraints that I define, some certain expression is valid. And the things that are valid are these that we want to check for validity are these constraints, right? Because the constraints, we want them to hold for all users. We want them to hold in general. So if it says every user with role HR or support must be able to access the knowledge base, we want this to hold for, well, every user, all the users. So we're going to check for whatever configuration of user we have, this property should be true. And how do we check all the configurations, or how do we say that something works for all configurations? That's by basically checking validity. Now, how do we formulate? So we have a formulation of accessing resources of our table, but how do we formulate these constraints? So now let's just look at formulating formulating individual constraints. So every user with role HR or support must be able to access the knowledge base. So what makes it difficult to formulate this directly in propositional logic? Maybe this every makes it difficult, right? Because how do we say for every user? So the trick that we do for every user is we will check later with by checking validity instead of satisfiability. So the only thing we have left to do is we basically, let's ignore this every for now. And now let's have, so a user with role, HR, or support must be able to access the knowledge base. Now that's a bit easier because we don't have this like every user in there anymore. So, and we know how to express the role, HR or support, right? So how do we express that the user has the role HR? We have some Boolean variable for this, right? Is HR, exactly. And how do we say that a user has the role support? Is support. And how do you say or? Or. Very simple, nice. So this actually means that our constraints, we have a very nice language to express them quite straightforward, right? So that's good. Maybe we had a little bit more trouble expressing our table, but once we get the table thing right, we want these constraints to be easily expressible, because that's the stuff people might experiment with and write. So let's. I should have copied the text. Let me copy the text as well. So we have these constraints. I'll just copy them so we have it side by side. So now we can just quickly read this and match it with this, or the other way around. So if we wouldn't have this on the bottom, what would this mean? This last constraint here. It says access to firewall and access to accounting, not. So this means if we would have a user, if the SAT solver would spit out a user that does have access to the firewall and accounting, we have a problem, because then it violates this, right? So basically here, that's no user may access the firewall and accounting at the same time. And the middle one, only users with role admin may access the firewall. So if you're not an admin, this implies that you are not accessing the firewall, right? So these constraints are now slightly easier than expressing the table, but of course we need to analyze both of them together, because now we want to make sure that these constraints are valid given the constraints on the table. So what we want to check is that the constraints are satisfied if the rules semantically entail the constraints. So the rules in our role-based access table, this is what should make sure that our constraints are satisfied, right? Because the role-based access table is our configuration, and we want to check whether the constraints are satisfied. So if we say rule 1, rule 2, and rule 3, because we had those three, each one for like access to this, and access to that, and access to this. So I think it was like access to knowledge base, access to accounting, access to firewall. These constraints should entail the constraint that we're checking. So how do we write that? We said that we can get semantic entailment by checking validity. So we just have to take our formula with these rules, plug them into this strange nested format, and then we can check that this formula is valid, whether this formula is valid. And if it is valid, then it means that our constraint holds, right? So yeah, let's just do that for the first one. So now it's all this nesting. So what's the first constraint that we have here? So is HR or is support, we need access to the knowledge base. So let's check that. I'm just going to write it down here. Oh, okay. Is HR or is support would imply that we have access to the knowledge base. And of course, this would not be in an end, but this would be our last kind of nested implication. And then we said, well, this all needs to be nested further and further and further. You can sit down with a piece of paper and see whether you really need all these nestings or whether you can rewrite it nicer. So there is a way to rewrite it in a more nice way. And then here the last implication like that. Now I hope I didn't make any mistakes with the yeah, with that. Do we have resizing of the editor?
No.
No.
But this colorizing of bracket is useful.
Okay. Wait, and if I... Is there an easy way? No.
You can...
The editor doesn't become wider? Is it now wider?
Yeah.
How far can I go? No. Okay.
768.
Okay. Yeah, so we basically have this do we need a parenthesis? Let's check our attainment. Yeah, so basically the first rule implies, and then in parentheses everything else, and then the pattern just continues until the last rule implies our constraint. So now I hope that this is what we have written here. Yeah, first parenthesis opening, which is closing down here. And then this thing implies, again, this other implication. Now, if we check just satisfiability, let's do that. What are we going to get? A parsing error. Okay. In line 5. Why? Expected closing parenthesis? Are we missing one?
I think
we have the red one. No, wait, no, they're green. This one. Ah.
line 3, this one is started. It's been closed, I think. The
So
first one, the blue one.
Yeah, this blue one?
Is not closed.
Ah. And then what is this blue one? And what is this? This matches that.
This one is first one.
So this one is closed, right? Then we have, let's just break them down in lines. So I'm always grouping the expression, and this blue one is that blue one, right? And then here, So what's the 5? Is that somewhere here? Anybody see the syntax error? And we can try to randomly add. Not fixing it. Okay, so here we have an implication between something in parentheses and this access to knowledge base. Then we have parentheses closed here.
Maybe it's the line break for the parentheses in line 6, but it should not. Maybe.
Should we move this back up?
Because it works on my side. I basically just type what you did.
So how come? What's the problem? Let's do another. And we can move it. Which one is it? Oh, what is the why does it say still the same line number? 530. This is not. Is this position 30?
Some minutes ago did not compile.
6-2.
Did not reload.
Oh wait, do we need another one here? In this implication, maybe? How did we? Yeah, so we didn't have yeah. So we basically had an implication, and then I think those implication and this implication, they both bind the same strength. So we had basically A implies B implies C, so it couldn't resolve which one first because they both have the same strength. I forgot the inner parenthesis around yeah, this guy basically. This parenthesis, the green ones, that's the ones I forgot. Okay. Now we checked satisfiability. We checked whether our constraint is yeah, somewhat here implied whether this is just satisfiable. So all we get is we get an example where the constraint yeah is satisfied, but we don't really want to check validity. We don't want to check satisfiability. We want to check validity. So for all possible ways to make these to satisfy these rules. So this means for all possible users that I can configure based on my access table, I want to check whether this constraint holds. And that's why we need to check validity, and we get it's a valid formula. So all the constraints that I could come up with, all the users that I could configure. So the ways that I can configure them is basically by giving them all kinds of roles and permissions according to the table. So according to the table, that's the first 3 constraints here that should make sure that everything, the access is only according to the table, right? And then I want to check whether my constraint is then semantically entailed. So now let's do the one with not admin, not access to firewall. So should be easier now. So if we say not is admin implies not access to the firewall. And it's again a valid formula. So basically, also this constraint is fine. We don't need to change the table because the left side of the semantic entailment always remains the same. That's basically the role-based access table. Only the right side, because that's the constraint we want to check of this semantic entailment. That's what we need to change. And now the last one, if we don't have, yeah, so nobody has access to the firewall, and access to accounting. So nobody has access to accounting and access to the firewall. And we run it, and it's an invalid formula. How come? If I scroll down, we're going to see a falsifying assignment, or an assignment that shows that this is not a semantic entailment. So how can somebody have access to accounting and access to the firewall? That's not good, is it? So let's look at the assignment here. We see access to firewall and access to accounting. And access to the knowledge base, so basically access to everything. And then we see how can somebody have access to everything? By being an admin and HR. So basically, if there is a user who both has the role admin and the role HR, then they actually do have access to the firewall and accounting. So what does it mean for our constraint? So we said the original problem we wanted to look at is given this role-based access table, are all our constraints valid? Are all the constraints satisfied given this role-based access table? And now that we got a negative answer, we see no. This constraint is not necessarily satisfied given this role-based access table. So is there anything we did wrong? No, we really found an issue. If somebody really has both roles, HR and admin, then yeah. So is there any way to fix this? Sorry? We could add a new constraint, but yeah, this would not be a constraint that we want to check against the role-based access table, right? Because we still know this would fail. So these constraints, we individually check them, right? So this constraint is completely independent of this, and it's completely independent of this, because these, we only check them on the role-based access table. So if we want to make sure that this constraint is satisfied, how would we ever do this? If you can only change the role-based access table but nothing else, that's not good, right? Because you would have to, how would you make sure that this never happens? So we know that if somebody has a HR role, they have accounting. And if somebody also has the admin role, they have the firewall. So what we really would maybe want to say is that nobody can be HR and admin together. Something like that, right? But that's not expressible in our table, right? Because the table can't express really disjointness between roles. So we could add this maybe as a constraint. And then if we want to add it as a constraint to our formula, how would we? Now that's a different kind of constraint, because it's not a constraint we want to check satisfiability of. It's a constraint we want to basically add on the level of the table, on the level of our configuration. We would have to say, but actually nobody can have those two roles together. So where would I add them? Where would I add this role, this new constraint? I would have to add it on the left side of the semantic entailment, right? I would have to make a rule star, and then I would have to make sure that this still semantically entails all the rest. So what's the easiest way to add something to this semantic entailment? I just put parentheses around everything and make it the first rule. And what would my first rule look like? How do I say that nobody can have HR and admin roles at the same time? Sorry? Is admin and is HR. Yeah. So basically I say this should never happen. And now I added it to the left side of the semantic entailment. So it is now something, a business constraint. And I check my like validity constraint by taking this new constraint also into account. And now I have a valid formula. So now really this this constraint here that no user may access the firewall and the accounting at the same time, we have checked it that if we disallow that somebody has both roles, admin and HR together, then nobody can access those resources at the same time. Okay, so of course, by looking at this table, you can, yeah, check that manually. But if these tables get very large, then it's very difficult to check. So there, our SAT solvers are one good way to check them. Yeah, so here I put the permalinks. Okay. Any questions about this? Very good. So now we managed to check all the constraints in the role-based access example, and we will continue with an overview of the actual first exercise.